Hey there, science fans. Today we're talking about wind power. It's an amazing source of energy, and guess what? It's renewable. That means we can use it again and again without it running out. Pretty cool, right? Wind is all around us. It's a powerful force of nature, and we can harness that power to make electricity. Wind power is clean, and it doesn't pollute our air or water. That's super important for keeping our planet healthy. Plus, it helps us reduce our reliance on fossil fuels, which are harmful to the environment. So let's learn how we capture the wind's energy and turn it into something useful. You've probably seen windmills in pictures, or maybe even in real life. These towering structures are becoming more common as we seek sustainable energy solutions. They look like giant fans standing tall and proud, dotting the landscape with their sleek modern design. Well, wind turbines are like modern-day windmills, but with a high-tech twist. They use the same basic principle of capturing wind energy, but they do it much more efficiently. A wind turbine has a few key parts that work together seamlessly. First, there are the blades, which are like the arms of the windmill reaching out to catch the wind. They're specially designed to catch the wind and convert its kinetic energy into mechanical energy. The blades are connected to a rotor, which is the central hub that spins as the blades turn. The rotor is the spinning heart of the turbine, converting the wind's energy into rotational energy. It's housed inside a protective shell called the nacelle, which sits at the top of the tower. Think of the nacelle as the brain of the operation. It contains all the critical components inside the nacelle. Things get even more interesting. This is where the magic happens. We have a gearbox and a generator. The gearbox takes the slow, powerful rotation of the rotor and speeds it up. This fast spin is what powers the generator, which then converts the mechanical energy into electrical energy. This electrical energy is then sent down the tower and into the power grid, providing clean, renewable energy for our homes and businesses. Let's zoom in on those incredible blades. These blades are the heart of the wind turbine, the key components that harness the power of the wind. They're not just any ordinary fans. These blades are marvels of engineering designed to maximize efficiency and energy capture. Wind turbine blades are aerodynamically designed. This means they are crafted with precision to ensure they can cut through the air with minimal resistance. This means they're shaped to move smoothly through the air and catch as much wind as possible. The curvature and angle of the blades are meticulously calculated. When wind blows across the blades, it creates a difference in air pressure. This pressure difference is crucial for the blade's movement. The air pressure is higher on one side of the blade and lower on the other. This imbalance in pressure is what drives the rotation. This difference in pressure causes the blades to spin. The spinning motion is what ultimately generates electricity. It's like how an airplane wing generates lift, but instead of going up, the blades rotate. This rotation is harnessed to produce clean, renewable energy. The size and shape of the blades can vary depending on the location and wind conditions. Engineers design blades specifically for the environment they will operate in. In places with strong winds, the blades might be shorter and more robust. This design helps them withstand the intense forces they encounter. In areas with gentler breezes, the blades might be longer and more slender. This allows them to capture more wind energy even when the wind is not as strong. It's all about finding the perfect balance to capture the most energy from the wind. The right blade design can make a significant difference in the efficiency and output of a wind turbine. Remember the spinning rotor inside the nacelle? That's where the real magic happens. The rotor's rotation is transferred to the generator through a series of gears. The gearbox increases the speed of the spin, making the generator work more efficiently. Now, inside the generator, we have magnets and coils of wire. When the magnets spin past the coils, it creates an electrical current. It's like magic, but it's actually science. This process is called electromagnetic induction. The electricity generated by the wind turbine is then sent down a cable inside the tower. From there, it travels to a substation where it's converted to the right voltage for our homes and businesses. Section 5, Power Grid, sharing the energy. Once the electricity from the wind turbine is at the right voltage, it's sent out into the power grid. The power grid is like a giant network of power lines that connects power plants to our communities. Think of it like a highway system for electricity. The electricity from wind turbines joins the flow of electricity from other sources like solar panels, hydroelectric dams, and even traditional power plants. This interconnected system ensures that everyone has access to reliable electricity no matter where it's generated. So when you flip on a light switch, the electricity might be coming from a wind turbine miles away. Section 6, horizontal versus vertical types of turbines. Most of the wind turbines you see are called horizontal axis wind turbines, or HOTS. They have their blades spinning on a horizontal axis like a giant fan. But did you know there are also vertical axis wind turbines, or VOWs? VORTs have blades that spin on a vertical axis, kind of like a giant egg beater. They look quite different from HORTs, but work on the same principle of capturing wind energy. HORTs are more common because they're generally more efficient at capturing wind energy, especially at higher altitudes. VOWs have some advantages too, like being quieter and working well in turbulent wind conditions. They're often used in urban areas or on rooftops. Section 7. Wind farms powering our world. Now imagine a whole bunch of wind turbines working together. That's called a wind farm. Wind farms can be located on land, known as onshore, or in bodies of water like oceans or lakes, known as offshore. Onshore wind farms are common in areas with vast open spaces and strong winds. Think about wide open plains or rolling hills. Offshore wind farms are becoming increasingly popular as we explore new frontiers in renewable energy. Wind farms generate a significant amount of clean electricity. They're like giant power plants, but instead of burning fossil fuels, they harness the power of the wind. This helps reduce our carbon footprint and combat climate change. Section 8, challenges we face. Keeping the wind flowing. Wind energy is a fantastic source of renewable energy, but it does come with its challenges. One of the main challenges is the intermittent nature of wind. Wind isn't always blowing, and its strength can vary. This means that wind turbines don't generate electricity constantly. Sometimes they produce a lot of power, and sometimes they produce very little. Another challenge is finding suitable locations for wind farms. We need to consider factors like wind resource potential, environmental impact, and proximity to the power grid. Balancing the benefits of wind energy with other land uses can be tricky. Section 9, future of wind energy. Innovation never stops. The future of wind energy is blowing strong. Scientists and engineers are constantly working on new technologies to make wind turbines even more efficient, reliable, and affordable. Imagine taller towers reaching higher into the sky to capture stronger winds, or blades with new materials that can withstand extreme weather conditions. We're also exploring ways to store wind energy so we can use it even when the wind isn't blowing. As technology advances, wind energy will play an even bigger role in powering our world. It's an exciting time to be a fan of clean and sustainable energy. Section 10, conclusion. A sustainable future blowing in the wind. So there you have it, the amazing world of wind energy. We've learned how wind turbines capture the wind's kinetic energy and transform it into electricity. We've explored the different parts of a wind turbine, from the blades to the generator. Wind energy is a powerful solution to our growing energy needs. It's clean, renewable, and good for the planet. And as we continue to innovate and invest in wind power, we can look forward to a brighter, more sustainable future. Remember, science is everywhere we look, even in the gentle breeze or the powerful gusts of wind. By understanding how things work, we can make smarter choices and create a better world for ourselves and generations to come. Stay curious. Section 11, glossary. Understanding the terms. In this section, we will delve into the key terms and concepts that are essential for understanding wind turbines and their operation. Aerodynamic, designed to reduce wind resistance and improve efficiency. This design is crucial for maximizing the energy output of wind turbines by allowing them to capture more wind with less drag. Electromagnetic induction, the process of generating electricity by moving a magnet near a coil of wire. This fundamental principle is what allows wind turbines to convert kinetic energy from the wind into electrical energy. Gearbox, a mechanical device that changes the speed and torque of rotating shafts. In wind turbines, the gearbox is essential for adjusting the rotational speed of the blades to match the generator's requirements. Generator, a device that converts mechanical energy into electrical energy. The generator is the heart of the wind turbine, transforming the mechanical motion from the blades into usable electricity. Grid, a network of interconnected power lines that distributes electricity. The grid ensures that the electricity generated by wind turbines reaches homes, businesses, and other end users efficiently. Intermittent, occurring at irregular intervals, not continuous or steady. Wind energy can be intermittent, meaning that the power output can vary depending on wind conditions. Kinetic energy, energy of motion. Wind turbines harness the kinetic energy of moving air to generate electricity, making them a vital part of renewable energy solutions. Nacelle, the housing at the top of a wind turbine that contains the gearbox, generator, and other components. The nacelle is a critical part of the turbine, protecting these components from the elements. Renewable energy, energy from sources that are naturally replenished, such as wind, solar, and hydro. These sources are sustainable and help reduce our reliance on fossil fuels. Rotor, the rotating part of a wind turbine that consists of the blades and hub. The rotor captures the wind's energy and transfers it to the generator through the gearbox. Turbine, a machine that converts the energy of a moving fluid, like wind or water, into rotational motion. This rotational motion is then used to generate electricity, making turbines a key component in renewable energy systems.